In the clear morning hours, the airbase buzzed with activity as preparations for the mission reached a critical stage. The hum of generators, the beeping of electronic systems, and the clatter of tools echoed across the flight line. Ground crew members moved swiftly and with discipline, their actions reflecting the results of rigorous training. Today's task was vital: to prepare several F-16 Fighting Falcons, fully armed and mission-ready, for a live bomb drop test, an operation designed to evaluate the accuracy, effectiveness of the munitions, and the pilot's combat readiness in a realistic, simulated strike environment. Within one of the base's fortified munition storage shelters, a specialized ordnance team worked swiftly and carefully, clad in flame-resistant uniforms and protective face shields. They gathered around a pallet loaded with a GBU-38 Joint Direct Attack Munition, JDAM, a precision-guided bomb equipped with GPS and inertial navigation systems. The technicians meticulously verified serial numbers, fuse settings, and weapon configurations, cross-checking against mission-specific loadout requirements to ensure everything was configured for accuracy and safety. The F-16 selected for the mission stood ready on the flight line, its airframe gleaming faintly under floodlights. Maintainers moved around the aircraft performing system diagnostics, checking hydraulic integrity, fuel levels, oxygen supply, and avionics functionality. The aircraft's targeting pod, crucial for visual and infrared identification, was calibrated to align precisely with the JDAM's guidance system. The synergy between pilot and machine would rely heavily on this equipment working flawlessly. Nearby, an experienced load crew began the delicate process of affixing the JDAM to the aircraft's underwing pylon. Every bolt, suspension, lug, and electrical connection had to be secured perfectly. A single error in this process could result in a catastrophic failure during release. As they worked, one crew member monitored the connection through a handheld diagnostic tablet, confirming that the arming wire and guidance interface were fully integrated with the aircraft's central fire control system. At the same time, a group of mission planners gathered in a secure briefing room with the test pilot, a seasoned officer with multiple deployments and hundreds of flight hours in combat scenarios. The planners reviewed satellite imagery of the test range, provided estimated wind conditions, and shared target coordinates, which would later be uploaded to the aircraft's mission computer. Every piece of this operation was governed by data, discipline, and trust in the capability of the team and the machine. With the bomb now mounted and secured, the ground team ran a final weapon check using the aircraft's onboard system. Green indicators on the loadout monitor signaled that the JDAM was communicating correctly with the targeting computer. Once satisfied, the chief armorer signed off on the live munitions log, officially transferring responsibility of the weapon to the pilot. The aircraft was now considered hot, and access to the area was restricted to essential personnel only. Meanwhile, another maintenance crew double-checked the F-16's power systems and radar functionality. They inspected the data link antenna, mission recorder, and countermeasure systems to ensure nothing would interfere with the bomb drop sequence. The stakes in live testing are always high. Every parameter must be exact, every checklist completed, and every wire intact. At precisely 0600 hours, the test pilot emerged from the operations building, dressed in a full flight suit, helmet under one arm, and mission tablet in hand. Her stride was steady, confident, yet focused, years of training etched into each step. She was mentally reviewing every phase of the mission: startup procedures, taxi routes, weapon arming protocols, and emergency contingencies. Each component was as important as the next in this finely tuned operation. As she walked across the flight line, she was met with respectful nods from the ground crew. There was no room for small talk, only a shared understanding of the importance of what was about to unfold. She ascended the ladder into the cockpit and began the pre-flight ritual, flipping switches, adjusting her seat, setting radio frequencies, and inputting the mission parameters. Each click and beep brought the aircraft closer to operational readiness. Once fully strapped in, the pilot placed her helmet on and connected the oxygen hose and communications cable. Her voice came through clearly over the intercom as she called out pre-flight confirmations with the ground crew. The cockpit displays lit up in shades of green and amber, and the F-16's fly-by-wire system engaged, giving her tactile feedback through the control stick and rudder pedals. She adjusted her HUD to display bombing parameters and GPS alignment data. Outside, the ground crew finished their final walk-around inspection. They removed the wheel chocks, retracted maintenance stands, and signaled the go-ahead for engine startup. The pilot responded by initiating the engine sequence, and within seconds, the sound of the powerful Pratt & Whitney F-100 turbofan roared across the tarmac. Vibration coursed through the aircraft as control surfaces flexed, responding to input checks. With the aircraft now fully operational, the pilot taxied to the designated runway. The tower issued clearance, and the F-16 turned onto the center line. After a brief pause and a final glance at her instruments, the pilot advanced the throttle. The engine howled as afterburner kicked in, propelling the aircraft down the runway at tremendous speed. Moments later, the nose lifted and the F-16 ascended sharply into the clear morning sky. As the jet climbed to altitude, the mission entered its next phase: navigation and target acquisition. The pilot adjusted her heading toward the test range, maintaining a steady climb and scanning the radar and navigation displays for any anomalies. The target coordinates were already uploaded, and the aircraft system began calculating optimal drop parameters based on speed, altitude, and environmental conditions. The test range was located deep in a remote desert zone, surrounded by controlled airspace. As the aircraft approached, long-range tracking radars and optical cameras were activated by range control teams. These systems would record every second of the bomb's descent, capturing data on accuracy, velocity, and impact effects. The mission would be judged not just by a successful drop, but by how precisely the munition struck its intended aim point. The pilot entered a low-speed loiter pattern as the aircraft neared the initial point of attack. She brought the targeting pod online and zoomed in on the desert floor below, where visual markers denoted the target zone. The HUD displayed a countdown to weapons release, calculated in real time based on her position, airspeed, and trajectory. She made minute adjustments to align perfectly with the attack vector. As she neared release altitude, the onboard computer finalized its predictive calculations. The aircraft maintained a precise glide path, guided by both inertial and satellite navigation systems. At the exact moment indicated by the targeting solution, the pilot pressed the release switch on her right console. The JDAM detached cleanly from its pylon and began its programmed descent, controlled by aerodynamic fins and a smart guidance kit. Below, the bomb sliced through the atmosphere, guided by internal sensors constantly correcting its trajectory toward the GPS-designated point. On the ground, high-speed tracking cameras recorded the descent from multiple angles, while sensors embedded in the target zone measured shock waves, impact precision, and blast pattern. Within seconds, the bomb struck its target, a large steel-plated structure designed to simulate enemy infrastructure. The explosion sent a towering plume of dust and debris skyward, and observers in hardened bunkers confirmed visual impact. The crater left behind indicated a successful hit, and telemetry data from the bomb confirmed all onboard systems performed as expected. The pilot circled the target area for a final visual confirmation, using her targeting pod to assess damage and send a real-time video feed back to command. With the test now complete, she initiated her return sequence, banking the aircraft westward and climbing to a cruising altitude. As she returned to base, mission controllers and analysts began sifting through the first wave of data, comparing it to expected results. Every aspect of the flight GPS accuracy, drop timing, bomb orientation, blast effect was logged and transmitted to testing centers for full post-mission analysis.